So in this video, I'm going to give you a developer's perspective on Ollama, and I'm going to tell you everything that you need to know for this interface, and I'm going to give you how it fits in the overall schema of all the AI development tools that we have as developers and how I see it panning out in the future. I'm going to tell you everything you need to know about this in this video. So when large language models were introduced, they used to run in these big organizations infrastructures, and we used to be able to interact with them using API calls. For example, if you were a Python developer, you would probably install a Python package. If you were a Node.js developer, you would install a npm package, and you would use that package as an interface to send API calls to these backend cloud-hosted large language models and get JSON response back. Over the years, we found out that that approach has its limitations. Not only the fact that we would get eventually rate limited, but also in a lot of cases, sending a query back to the API and waiting for 5 seconds to get the response back is not just going to cut it. If I take an example of, let's say, if you're building a solution for a healthcare client, then you might be legally restricted from sending sensitive patient information back to these cloud-hosted large language models. Or if you're working for a financial industry client, then also you might not be able to send sensitive information back to these large language models that are hosted in the cloud. Also, there are certain other use cases. So if you're building an automatic captioning plugin for a live streaming app or a video calling app, then you are not going to send a request to this backend API and wait for 5 seconds, right? So you'll have to run these large language models on the client. So basically you need client-side rendering in such cases. And there are two ways the development community has tried to solve it. One is WebML. So we're talking about the TensorFlow.js library, which is very popular, or Hugging Faces, Transformers.js library. All these libraries allow you to fetch a quantized version of these models, which is much smaller in size, probably 100 MB or so. And we get to fetch these small quantized models and store them in browser cache and run inferences based upon that. So you'll be able to run real-time inferences. I have some projects that I worked on, and I have made a video where I am using the TensorFlow.js's Coco SSD model. I'm fetching the quantized version of it, and which is about 100 MB in size, and I'm running real-time inferences to detect objects from the webcam feed. And whenever a person is detected, I'm recording a 30-second clip and saving that video in the downloads folder. So for this kind of use cases, you are not going to send a request to the backend API frame by frame that you are getting from the webcam feed. Rather, you want to run real-time inference that is running on device. But as you can see, for WebML, you are limited by the fact that whenever you'll be loading this web page, the model also has to load. Obviously, the model has to load only once until or unless you clear the browser cache, but still you are limited by the fact that you don't want this model to load for a very long time, because that is not going to be the right user experience. On top of that, there are certain other apps that are also running on a desktop that might also want to use this large language model inferences, right? So let's say, for example, I build this app as a web app, and what if I want to package this and share it as a desktop app? Right now with WebML, I'm only bound within the web browser. So if I take the example of live captioning, where I'm building a plugin for, let's say, for example, Zoom, where I want to create live captioning for this video call, then WebML is just not going to cut it. I need these large language models to be running in the desktop. Or if I take another example, so Adobe has a nice tool. If I go to Adobe Speech Enhancer, so in this you get to upload a very long audio. And so as you can see, it is about 43 minutes of audio. You get to upload this audio, and it enhances the audio and makes it studio quality. So it not only suppresses the noise, it also applies some artificial intelligence based settings onto the audio so that it becomes very high quality. You might want to try it. This is really good. But the problem is that, let's say, for example, you are working on DaVinci Resolve and you want the audio quality to be enhanced by this by this AI. You'll have to export that as a audio file. You'll have to upload it here, then again align the audio with the video, and then do it for all the audio tracks that you have recorded. Think about all the B-rolls that you might have recorded and aligning all of them, and doing it by uploading it to this web app. if you had this AI models running in the desktop, and if you had created a Resolve plugin, you'd be able to utilize that locally hosted artificial intelligence model, and you'd probably be able to do it within your desktop environment, within the Resolve, without leaving the environment of the DaVinci Resolve. So that is the basically the promise of Ollama. So this is nothing but an interface that allows you to fetch these large language models onto the client environment. So they are saying we allow you to fetch and run these large language models on consumer GPU. So if you have a dedicated GPU or some extra RAM that is going to be more power to you, you'll be able to fetch and run even larger models. But on basic average consumer GPU, this allows you to fetch these models and run. To set up Ollama, you'll have to go to this Ollama.ai and click on this download. But before I click on this download, I'm going to go to the models page where you'll be able to see that the list of models is quite large, and Llama 2 is one of the most popular models that is developed by Meta. And if I go to this tags section, you'll be able to see that you can run, or rather pull, this model using this command. So when you will run this command for the first time, this model is going to be pulled onto your desktop, and it is going to spin up an instance of that specific large language model. And as you can see, the size is 3.8 GB. This is a default model that gets pulled using this command. But then again, there are so many other versions. So the default version is basically the 7B version and the chat fine-tuned versions of it. So if you read the documentation, so as they mention it here, and each models are different, obviously. This Llama 2 model is a large language model. There are so many other large language models, like for example Mistral, which is a more popular model at this moment. So they mentioned that the 7B model requires 8 GB of RAM and the RAM requirements and everything, and 70B requires 64 GB of RAM. And they also mentioned details about the model variants. They mentioned that the chat version is basically the the fine-tuned version for chat use cases, and the text version. So if you use the tag text, you get the model without the chat fine-tuning. So if I go back to the tag section, this is the default version, which is the 7B chat version that you get, but then you get the 13B version as well, and obviously the text and chat versions of those models as well. And if you scroll down to the bottom, you will see that you get to pull the actual model in itself, that is the 70 billion parameter version with floating point precision of 16, and that is how Meta trained this model. And as you can see, that is of size 138 GB, and you can pull it using this specific tag. So if you have the capability, ideally you get to pull the full sized model and run it locally and run inferences on that. So let me show you some other models. So Mistral is gaining a lot of popularity these days due to the fact that, as they have mentioned, that it outperforms the Llama 2's 13 billion parameter version. The 7B Mistral actually outperforms the 13 billion parameter version of Llama 2. So if I go to the tag section, the default version is the 7 billion version, 7 billion parameter version, which is about size 4.1 GB. And if you remember, the 13 billion version of Llama 2 was about 8 GB in size. So it's about half the size, which has outperformed in all the benchmarks. And that is why Mistral is one of the most popular large language models at this moment. And if you scroll to the bottom, you will see the floating point 16 precision 7 billion parameter version is only about size 14 GB, much smaller large language model. And you get to pull it using this specific command if you wish to do so. So let me show you some other models. So there is this model called Llava, which is a multimodal model. And as you know, GPT-4 is also a multimodal model, and a lot of people are saying that 2024 is going to be the year of multimodal for AI. As you know, that Apple has launched its Vision Pro, and Meta has launched with the collaboration of Ray-Ban its Meta smart glasses. So you might have seen some videos of the multimodal applications, and Llava is also, you can say, is a completely free open source alternative to GPT-4, and it does not generate any image, but it can take as input an image or multiple images and text, and it can respond based on the context that it sees in the image as well as in the text. There are some other models that are like Code Llama, which is also very popular. And this is also developed by Meta. And if you want to generate some kind of solution for the coders, then this specific LLM can be of use to you. So with that, let me go ahead and download this. So as you can see, it is not yet available for Windows. If you go to the GitHub and do some digging, you will find that there are some workarounds that you can use to run it on Windows. But right now, the official support is for macOS and Linux. So as you can see, this is only 160 MB in size. So this is basically downloading the interface using which you will be able to interact with these backend large language models. By that I mean you'll be able to pull those models onto your desktop. You'll be able to run those models, spin up instances of those models, and you'll be able to also interact with these models using by writing some kind of text and get inferences back as a response. On top of that, it also spins up a web API in your local host, and you get to interact with it by sending a post request to it. So if I go to any of the models, let's say I'm going to the Mistral model. So there are two ways of interacting with it. One is using the CLI and another is using the API call. So you get to send a post request to a locally hosted web API, and that is exposed from this 11434 port, and you get to send a post request and you get a response back. So I'm going to demo that just in a bit. So after that is downloaded, I'll go ahead and install it. I'll click on open, and it says that it works best if you move it to applications directory. This is very straightforward installation for macOS, and it is moved to applications. And now I can search for Ollama, and as you can see, it just comes up in the taskbar. That means the Ollama is running in the backend. The interface is running in the backend. It hasn't yet spun up any instance of any large language model. In fact, we haven't even fetched any large language model onto our desktop. So for that, we'll have to open the terminal. So I'm going to bring up the terminal, and we can run any model here. So let's say, for example, I want to first fetch this Llama 2 model, and I can go to the tag section and choose a specific model that can be like the text model, which is without any fine tuning, or we can get the default chat model, or I can get the 13 billion parameter version, and whatever I want here. But I'm just going to go with the default one, which is Ollama run Llama 2, which is also the command we see in the overview. So I'm going to run this command here in the terminal, and it is going to pull the model first. So as you can see, the 3.8 GB sized model is being pulled onto our desktop, and as soon as it is pulled, it is going to spin up an instance of that model and will allow us to interact with it using this command line interface itself. So this is going to take some time depending upon your internet connection. So I'm going to come back when this is done. So as you can see, it has downloaded the model first and then some additional small files, and it has spun up an instance of the Llama 2 model, and it allows us to interact with it via the command line interface. So I'm going to type a simple message here. Okay, so it says that why don't scientists trust atoms because they make up everything. I find that pretty amusing. It's not too bad. So let me stop this and open a new model. So you can hit Control D, and that is going to stop the instance of this Llama 2, and that is going to free up any resources that it's using. But it is going to keep this model. So next time if you want to run, you just run the same command, and it is going to just spin up the instance of this large language model. Now let me bring up the Mistral model. So I have gone ahead and fetched this Mistral model using Ollama run Mistral, and it has also spun up an instance of the same model. Using Mistral model, we can also do large language model tasks. So let's use it for summarizing a URL. Earlier when ChatGPT were launched, that time we had the ability to paste in a URL and get a summary of that specific web page, but I don't know why they have stopped that feature. But now we can do that using this on-device large language models. So I'll go and fetch Eon essay. This is one of the websites that are really good for reading essays, and these are usually very long essays. And I'm just going to copy this URL and paste it. Before that, I'm going to say that please summarize this URL, and this is going to start summarizing. This is all running on device, and I really don't know about the content of this essay. So I think it is doing a decent job as it picks up the years and everything. It's a very long essay, and the summary is also pretty long. So I think this is doing a really good job of summarizing it. So this is one of the LLM tasks of summarizing URLs that you can run now on device by fetching these models. So let me go ahead and fetch a multimodal model. And for that, I'm going to use Llava, which is a completely free open source alternative to GPT-4. So you can pull this using this command. I have already pulled it. So if I run this command, this is just going to spin up the instance. So I'm going to stop the instance of Mistral by hitting Control D, and Command K will clear the terminal window, and then run the command to spin up an instance of Llava. So what I've done is that I have gone ahead and saved a few images on my desktop, and I'm going to first pass along these images and then ask questions based on that image. So I can get the path of that image by hitting Command I. As you can see, this is a coffee shop's image, and let's see how this multimodal model does with this image. I'm going to copy the path here, and I'm going to write what is this image about, and I'm going to say 1.jpg because that is the name of the image. So it says that it has added the image in the context and then trying to generate a response. And that's really a lot of details. So if I open the image up, you can see the inference that it has generated is really good. It says that it not only detected that two chairs and it is placed in front of a door. It also says that there's a coffee cup indicating someone has been enjoying a hot beverage, and there are handbags and everything. It can also detect the cars. I think these are cars covered. I'm not sure, but it says this, it also detects the objects that are outdoors, and I'm not sure if it is actually correct, but it is also saying that it is suggesting uh, that this is close to a roadway. I think that is really good. So let's try it with another image. So I'm just going to change the name here because I have named them as 123. Let me bring up that image. But I think that is a lot of details, and it also says that possibly it's a promotional photo. So it is not saying that this is a promotional photo. It says that there is a likelihood that this is a promotional photo. And I think this is indeed a promotional photo, and that is really good inference in my opinion. So let's try it with the third image, and I'll bring up the image here. So this says I like the fact that this actually talks about the possibilities, and as it seems as though, and what could have been the case and those kind of things. And it also talks about the mood that it sees in the picture, that it seems as though it has been left behind unattended for quite some time. And this is really good in my opinion. I'd like to know what you guys think about it. And the environment appears to be deserted, so it talks about that mood, and it also talks about what might be the possibilities. And please note that this is all running on device, and I'm using a M1 Mac, which is very old. So if you have M3 Mac or a dedicated GPU, then you might actually have a much better experience, and you might as well pull in even a larger model and get much more detailed inference out of it. So let's throw in a little bit different task at it. So I have pulled in a economics image. So this is basically the 2000 years of economic history in one chart. This shows the GDP share of different countries over the last 2000 years. So let's see how this multimodal model does for this specific image. So I'm going to write, what do you infer from this image? Well, I think that is a very generic inference. I mean, it's an infographic and it talks about the GDPs of different countries, and that is very generic. So let me try with a different prompt and see how that goes with it. Well, so it did detect the year as a axis, and when I prompted it with the trend keyword, it detected year as a axis, but uh, unfortunately it did not do a pretty good job. I mean, the spike that it is talking about is probably this one, 19th, mid 19th century, so that means it would be 1850s. So this is probably the spike that it is talking about, where there is an increase in the in the GDP, but that is actually not the case because this is 100%, because this is a 100% in total. So some countries have grown, and that has come at a cost of other countries. So it has not been able to detect that, probably because the country names are on the right side, and on the left side there is this percentage chart. And I would agree that this is probably one of the not a very easy chart to read for a machine learning model, but uh, I would like to test it with other charts, or I would like to test this image with GPT-4 and see how that performs. So these are three very popular models that we tried. Also, there are so many models. You also get some really open source, completely open, uncensored models. So these are Llama 2's uncensored model. So creator George Sung and Jared Hope, they have written a very nice article if you are interested into the philosophical aspect of whether a open source model should have alignment. They are talking about what are the alignment issues and what are the philosophical aspects of having alignment built into open source models. This does show you that how this Ollama takes up the concept of truly open. So if you read through this article, they are making a very strong argument that there should not be any alignment built into the truly open large language models. And the way these large language models are trained does not have this censoring or alignment built into it. These are built on after this training is done, these are built on top of it, and these alignments are usually influenced by pop cultures, and they're arguing that there should not be any one single popular culture that this model should follow, and it should be truly open. That is the strong argument that they are making in this article, and based on that ethics, Llama 2's uncensored model is built, and you can download and run it locally using this Ollama just by running this command. And if you are into the philosophical aspect of artificial intelligence and its impact on society, then this article is a must read. I'm going to put a link of this in the description, but again, you can just come to this Llama 2 uncensored models page, and at the bottom you get this link. With that, there is one last thing that I'd like to show, which is the accessing these large language models via this REST API. So we have already installed the Mistral large language model, and let's use the API route to send REST API calls to this locally hosted large language models. So I'm going to open VS Code, and I'm going to hit Command Shift R to bring up the Thunder client. And if this is not installed, you might want to use Postman, or if you want to use this Thunder client only, then you can hit Command Shift X to bring up the extension panel and search for Thunder client, and you can install this. So I'm just going to go to this Thunder client which is already installed, and I'm going to click on new request. I'm going to close this sidebar and send a post request to this localhost. So before I do that, if I go to this URL, which is, if I go to this specific port, it says that Ollama is running. So we'll be able to send API call. Ollama is running because we can see that this is coming in the taskbar. So let's send a API request. So here I'll be pasting that URL API generate, and I'll be sending a post request. In the body, I will mention the model name, and there is one thing I'll also add, which is the stream. I'll set it as false. So whenever a locally hosted model runs, it sets the stream as true. That is how you can see each of those tokens printed one after the other. But since we are sending it as a REST API call, I would like to get all the response at one time in one single JSON object. And how I know that is actually they haven't mentioned this API documentation link here, but I think they need to update that link in this model page. But if you go to any other models page, you get this link API documentation just under this API, and here this page actually serves for all the models. So you see Llama 2 here, you also see Mistral, you see the Llava, you see, if you search for Mistral, you'll get Mistral as well here. So this page actually serves the purpose for all the models, and this link should also be there in the Mistral API documentation. So as you can see, by default, it says that a stream JSON object is returned. So basically you get a stream object, but you can set the stream to false. So true is the default option, and when you set it as false, you get the whole response in one JSON object. So that is what I'm going to do here and hit send. So I'm sending a post request to a locally hosted web API with the body which mentions the model name as Mistral, and I'm just asking for probably okay, so let me ask something else. Let me ask like, what is the capital of India, and send. And we get the response. The capital of India is New Delhi, and it does give a lot of other responses uh, designed to build by prominent British architects and everything. A lot of details are given. You can format it in JSON format. So in the prompt, you can say that please populate the following JSON, which says, let's see how this goes. Well, it does. I mean, okay, so at least you can extract the JSON. So if you add a filter between this, just to extract a JSON from the string, then you do get the JSON and the answer in a nicely formatted way. Also, it does add another new line, and it says New Delhi is the capital city of India. So you get to format the response in a way that you want by just doing some kind of prompt engineering. But the point is that all of these are running in a locally hosted environment, and you are able to send a API request to this localhost port and get inference response back.